start streaming. Alright, well, we're back. Sorry about that. I thought I fixed the Wi-Fi issue, but, I guess not. Hopefully this is talking properly. If not, we're just gonna keep going, because, honestly, you hear the audio. It's just the videos on my part not super great. So, anyway. Let's go back to exact differential equations. What? This is not working now? Are you serious? Oh my god. I swear. It's annoying because, I have a really powerful computer. And it's... okay, well. Anyway. So, the proof for this previous statement up here that the partial of m with respect to y equals the partial of n with respect to x, proof for that is right here. So, since m of xy dx plus n of xy dy is equal to some function, the partial of some function with respect to x dx plus some function with a partial of some function with respect to y dy, we can go back up here and see that we used some function up here. So that's the reason why we're saying that there's some function. Now, since this is true, we can say that mxy dx equals the partial of some function with respect to x dx. They're equal. And the same thing with nxy dy equals the partial of some function with respect to y dy. So this is true. If this doesn't make sense, you can plug in f of xy equals xy into these equations in here, up here, and it'll be pretty easy to see once you do that this is true. So therefore, if we take the partial of m with respect to y, then we're going to take the partial. See, if we take the partial of m with respect to y, this over here, and then the partial of some function with respect to x, we take the partial of that here with respect to y, then that obviously equals the second partial derivative of f with respect to y and x. And if we take the partial of nxy dy over here, and we take its equivalent, the partial with respect to x of this as well, then we can see that all of these are completely equal. And this is the proof. So if this also doesn't make sense, you can plug in f of xy equals xy into this whole thing in here, this whole proof. And you will see that it's pretty straightforward why this is true. So, how do we solve a problem, an exact ODE, using what we just learned? Well, there's a pretty long procedure for this. It's about 7 steps, 8 if you're counting rearranging it in explicit or implicit form. So essentially, the first thing that we do is we check if the partial of m with respect to y equals the partial of n with respect to x. If this is true, then we proceed. If it's not, then it's a non-exact differential equation, but you're likely not going to get something that isn't equal. That this is not going to be equal. It's not really going to happen unless your teacher's weird, which who knows. Anyway, so the first step is taking the partial of a function with respect to x, and we don't take it, we essentially just write this down. That's the first step, because it just makes everything easier. Then you take the integral of that certain function with respect to x, and then you take the integral of mxy with respect to x. You hold y completely constant. Once you do that, here's a very important step. You get f of x y equals the integral of mxy dx plus some gy, which is an arbitrary integration constant. This gy, or g of y, is going to be very important to actually solving the whole equation. So the whole point of the rest of these procedures is to solve for gy. So you can get an implicit and an explicit solution for your exact ODE. Now the next step is, since we know that partial of m with respect to y is equal to the partial of n with respect to x, we're going to use that here in step 4. So we take the partial derivative of x with respect to y, and we take the partial derivative of essentially all of this here. We just like copy and paste that into there. And we take the partial derivative of that, the whole thing, including the integration constant. And by that, we know that this is equal to nxy. Then, since this is now equal to g prime of y, after we do this, we can solve for g prime of y. And since we're looking for g of y, we take the integral of this afterwards. So we solve for it. That's step 5. We just solve for g prime of y. Then we take the integral of it with respect to y, since it's literally only it's a function of y, so we take the integral with respect to y. Oh, and the reason that this arbitrary integration constant, we could say that it's with respect to y, is it's a constant. So essentially, since we're already integrating up here in step 3 with respect to x, any constant can also just be with respect to y. Like, it can be a function of y, since we were already integrating with respect to x. Alright, so then we rearranged the equation here in step 5, and then we took the integral of that whole entire equation, and we get, well, I skipped a step here. I mean, it was supposed to be, g of y equals this whole entire thing here, but I just went ahead and I solved separately, because what we do here in step 7 is we go back to step 3. Remember step 3, how I said it was pretty important? So we go back to step 3, and we plug what we solved for g of y into g of y. So essentially, we take this whole thing here, and then we plug it back into g of y. Right? And then we're not completely done with this here. This is almost the final solution. However, after this, depending on the problem, we either want to get an implicit solution or we're going to get an explicit solution. And we'll go over this in the example problem on how to do that. So after all of this, we can deduce that f of xy is equal to the integral of nxy, with respect to y, plus h of x, and therefore the derivative of some function x is equal to mxy minus the partial derivative of the partial derivative of the integral of nxy with respect to y. That's after. So essentially, it's just taking step 7 and then deducing this out of step 7. So let's move on to our example problem. Should be like up here somewhere. Oh my god. Yeah, here it is. Okay. So here's our example problem. Solve 2xy dx plus x squared minus 1. Is this even streaming? I'm sorry. Okay, it is. That's fine. God, I really need to fix my internet connection. This is so bad. But we're just going to keep going. Okay. Sorry about my handwriting as well. Okay, so the first thing we're going to do is we're going to label this as m, and we're going to label this as n. So this is m, xy, because you can see there's two variables, x and y, and then here, this is x, y. Now, what we're going to do is we're going to take dm dy, and that's going to equal 2x. And here, we're going to take dn dy, and that's going to equal 2x as well. Oh, sorry, that shouldn't be dy. That's dx. Sorry. dx, and that also equals 2x. So now that we know that these two are equal, we can say that this is definitely an exact ODE. The next step is to take some function with respect to x is equal to 2xy. So then we take the integral of that with respect to x here. And now we know that that f x y is equal to x squared y plus gy. Now, remember step 3, this is the most important thing because we're going to plug things back into here. Then the next thing we're going to do, we'll just go over here. So the next thing we're going to do is we're going to take the partial of f with respect to y, and we already know that that's going to be n of xy, which means that we take the partial of this of step 3. So that's the partial of x squared y plus g of y, and that equals n x y. And we know that equals x squared minus 1. So, then we just solve for g of y. So essentially the partial of this is going to be x squared plus g prime of y and that equals x squared minus 1. Then we solve for g prime of y. G prime of y equals x squared minus 1 minus x squared. For g prime y is just equal to negative 1. Then what we do is we take the integral of this with respect to y and the integral of negative 1 with respect to y. And therefore we get g of y is equal to negative y. Now remember step 3. So we go and we plug this back into there. So essentially we get fxy equals x squared y, sorry, not plus, minus y. Now, we're not done here. Now, we take the explicit solution, which we just sort of rearrange things. And the explicit solution would essentially be y equals c over 1 minus x squared. And then the implicit solution would be x squared y minus y equals some constant. And these here are the solutions that you're going to be looking for. So yeah, that's all we have for today.